Good evening. So in today's session, we are going to discuss about module 15. So which explains about Java input and output. There we are going to discuss about Java IO classes and interfaces, introduction to IO stream, and what are the types of streams that are available, and byte streams, character streams, and also we are going to know about text files versus binary files, and what is meant by random access files, and finally serialization and deserialization. Right. Now, coming to the introduction, Java input output involves, which is also to be termed as Java IO, which involves reading from and writing to external sources like files, network connections, and other input output devices. So here Java IO is nothing but reading data from the source and processing the data and writing that to the external sources, which are to be called as destinations, such as the sources and destinations may be files or network connections or other input-output devices. Here, Java provides a flexible programming interface for performing IO operations efficiently, input-output operations efficiently. So here you can see the visualization of input-output process. Here, source provides the data. Through the input stream, the data can be taken or read by the Java application. This Java application processes the data, and after processing, it produces the output. Through the output stream, it outputs the data or writes the data to the destination. Right. Now, here, Java input output is used to process the input and to produce the output. So here, Java uses the concept of a stream to make IO operations fast. So the Java, here we have a package, java.io, which contains all the classes and interfaces required for input-output operations. We can perform file handling in Java by using Java IO API, that is application programming interface. So here the Java IO API is placed in the java.io package. I already said you that there is a package named java.io which contains all the classes and all the interfaces which are required to perform Java IO operations. So java.io package generally involves reading basic information from a source and writing it to the destination. Now, what are the IO streams? So first of all, what is meant by a stream? A stream in Java represents sequential flow, that is unbroken flow of data from one place to another place, that is from source to destination. So it is required to accept data as input from the keyboard. The data in the form of stream may be bytes, characters, or objects, etc. Right. Now, for processing that data or for reading that data from the source or for writing that data to the destination. So here the Java stream is represented in mainly three streams. One is system.in, and other is system.out and system.error. Here system.in is the input stream, system.out is the output stream, and system.error is the error stream. Now, whatever the output we are getting or whatever the error message we are getting, both can be displayed on the screen only, right? And the input can be taken, for example, from keyboard. That's why we represented keyboard. Now here we have given the elaboration of those streams. System.in, this is a standard input stream that is used to read characters from the keyboard or any other standard input device. Now, system.out, this is a standard output stream that is used to produce the result of a program on an output device like a computer screen. Now, what are the various functions that we use for outputting the result on screen? So here we have different formats of the print function in Java. Here we are going to represent the basic print function print. So which is the method available in Java to display the text on the console or on the screen. So this text is passed as a parameter to this method in the form of string. Whatever the string I want to print on the screen, that text is passed as the parameter to this method in the form of a string. This method prints the text on the console and the cursor remains at the end of the text at the console. And the next printing takes place from that cursor, right? Now here, this is the syntax for using this print statement. So here, since this print method is present, is to be represented as the output string. Now here, system.out.print. So which takes a parameter in the form of a string. Now here you can see the example program which shows how we can use the system.out.print function. So here I have written a class and here I have written the main method and here I want to use the print method. Now just here I have written 3 print statements in my main method. Now these 3 print statements all are represented as system.out.print and here I have written 3 statements to print. Now whenever I run this program, I'll get this type of output. That is, first the statement, the string which is present in this statement is printed. That is, first it is printed. The cursor is to be represented here. So from here onwards, the second print statement will be published. Now here, this is the second print statement which is published. The cursor is present at the end. This is the third statement. This is published, right? So all are present in a single line. Whatever the publications that we are doing, all are represented in a all are to be represented on the console in a single line, right? Next version of that print function is println. So which is used to print the statements on the console in a new line. Every statement is to be printed on a new line, right? Next line, right? Now here, this is the example for using that print statement. So here you can see system.out.println. So here it takes a string as a parameter. Now here you can see demo print main method. Now here just I changed the function println. Instead of print, I used println. Now in that case, I get the output as like this. The cursor stays at the new line. From there, the second printing statement starts. So after printing this statement, the cursor comes to the new line. So here the next statement prints, right? So this is the println function. Now one more function is there in Java which used for format printing, which is nothing but printf, right? So earlier 2 methods are print and println methods. Now here printf function is also there in our Java. So here in system.out.print and system.out.println, we can pass a single argument. So here our printf statement takes multiple arguments. Now here you can see the example for writing that program. Now Java formatter class I have taken. Here I have taken main method. Now here we are taking x is equal to 100. I want to print that simple integer value. Since it is the integer, we are specifying the formats here. Here we are specifying the format of that value, which is nothing but %d. Here the %d is to be called as format specifier. So here this is a printf function. So which represents the format value, format specifier, right? Now here I want to print, so the pi value up to 2 decimals. Now here I want to print n value. So by adjusting some width. Here I want to print n value by adjusting some margin, right? Now whenever I run this program, I'll get this output. First it prints the simple integer x is equal to 100. Now here whatever the statements I have written, that will be printed, printing simple integer, which is a concatenator here. simple integer colon x is equal to %d. Here, for going into the new line, we are using \n. So in earlier case, for going to the new line, we can use ln statement, print ln, right? Here for going to the, since this is a format specifier, there are multiple arguments are there. So here we are using \n for going into the new line. So in the new line, this statement will be printed, formatted with precision, right? Pi is equal to up to 2 decimal values. I asked, it printed up to 2 decimal values. Now, here the next value formatted to specific width, 4 decimals it is formatted. So that's why 5.2000. Like that it printed. Formatted to right margin. Now here this is the right margin value that what it represented. Right. Now, here, so this is about printf function. So here these are the 3 print statements, 3 various formats, 3 formats of the print statements that what we use in Java. So those 3 formats are print, println, printf, right? So next, system.error. This is the standard error stream that is used to output all the error data that a program might throw on a computer screen. Whatever the error data that I want to throw on a screen, for printing that error data, we can use this system.error stream. Right. Now the same. So I want to throw the statements, error statements onto the screen only. So that's why here also for throwing all those statements onto the screen, here we are using the same print functions, print, println, and printf functions. Right. Now here this is a error statement. Right. Now here you can see. So here I have written java.io and class simple.io. So here I have taken public static void main method, which throws IO exception. If there any IO exception, that can be thrown here, right? Now, input stream reader. Here I am taking input stream reader class. Now here I represented null. Now storing the input. Now input is equal to system.in we are taking. Now we are asking to enter the characters and 0 to quit. Now here the char C. So whatever the characters we entered, those characters can be read by C. So here C is equal to char inp dot read. Here we are using the read function. Right. Here this is the stream reader. Stream reader means, so we'll explain those things later. Stream means a sequence of data. Right. Now, like that, whatever the sequence of data we entered, that sequence of data can be readed. Right. Now I want to print that sequence of data. So now while C not equal to character 0. Right. Now, whenever I want to print the output statement, now these can be printed. Now, whatever the input I given, for that input, each character will be printed. Since I used print ln, every character is printed in a new line. So whenever I entered other characters which cannot be read, there the main function throws an exception. That exceptional statement will also be printed on this output screen. Right. Now, next we are going to see types of streams. What the various types of streams that we are having. Mainly, we are having 2 types of streams. One is byte stream and other is character stream. Byte stream and character stream. Now, byte stream itself is having input stream classes and output stream classes, as well as character stream is also having input and output. In case of character stream, we call the input stream as the reader classes and output stream as the writer classes. So mainly here the character streams can be used for files. Here the character streams can be used for files. Here these byte streams can be used for just giving the input from standard devices. Right. Now here you can see byte stream. So what is byte stream? Byte stream classes are used to read bytes from and write bytes to an input stream. So whatever the data I want to read, for reading that bytes of data and for writing that bytes of data, we can use this stream. To input in another way, byte stream classes read and write 8-bit data. So all these byte stream classes read 8-bit data and write 8-bit data. We already know that byte means 8 bits, right? So using byte stream classes, we can save video, audio, characters, and so on. So here, whatever the classes I need for performing all these operations, all those are available in java.io package, right? So byte streams have a three-phase mechanism. That three-phase mechanism is nothing but split, apply, and combine. Now, what is a splitter? A splitterator divides the input data source into a stream. The Java splitterator interface is an internal iterator that divides the stream into small parts for traversing. Right. Now, the elements in the stream are processed. Apply means whatever the elements that are present in the stream are processed. So combining, after the elements have been processed, they are combined once more to produce a single result. Now here you can see the example. So first, whatever the program that I have, now first we will give the input stream, right? This input stream can be given in the form of byte stream. So here a splitterator is there. That splitterator splits the data and passes that data for processing. Whatever the input data is taken for processing. So now after that, the stream, the elements which are present in the stream are processed. These are all the elements which are present in the stream, which are processed. After the elements are processed at the destination, that can be combined once more to produce a single result. Whenever it is taking the data, it takes the single result, single input, and it produces the single output. But in the middle, Java splitterator works, which divides the data into different parts. Right. Now, that different parts are processed, then they can be combined to produce a single output. Next, the byte stream classes are classified into two types. One are the input stream and other are the output stream. Now, these are the abstract classes for all input output stream classes. Whatever the input output stream classes that I want to use, for all those, these are the super classes. Abstract classes, these are the abstract classes as well as super classes also. Now, input stream. Now, I want to talk about the input stream in the byte stream. Now, here you can see a stream that receives or reads data from a data source and sends it to a Java program is called as input stream. Now, here, this is the data source. The input stream takes the data from the data source and it reads the data. That data is passed to the Java program. So here, this is the process, reading data from data source into a Java program. The input stream connects the data source and a Java program as shown in the figure. Now here, this is the figure which shows connecting the input stream, data source and a Java program. Right. Now here, writing the data, how the data can be written. Output stream can be used for writing the data. A stream that takes the data from a Java program and sends or writes the data to the destination is called as output stream. So now output stream, now here you can see the output stream. So from the Java program, the output stream takes the data and writes it to the data sink. Sink is nothing but destination. Here, this is the data source. Input stream takes the data and reads the data and to the Java program. The Java program processes the data. After processing the data, it writes. That written data is taken by the output stream and that is passed to the sink. Right. That is destination of the program. Now here you can see an example for that. Here, this is a files example. We will see it later. Now, character stream. The character stream is used for 16-bit Unicode input and output operations. Now, byte stream allows only 8 bits, but character stream allows 16 bits. Right. Character streams would be advantageous if we wanted to copy a text file containing characters from one source to another using streams because it deals with characters. Right. So I already said you that it contains 2 bytes, that is 16 bits in size. Now, the character stream classes are also to be present in the java.io package and which are used to overcome the limitations which are present in the byte stream, that which can handle only 8 bits of data and which is incompatible to work with Unicode characters. The byte stream is incompatible to work with the Unicode characters. Right. Now, character stream classes are used to work with Unicode characters and which are available in 16-bit length. They can work with the characters, arrays, and strings. Right. The character stream classes can be divided into two types. Those are reader classes and writer classes. Whereas byte stream classes are divided into input, output stream, and output stream. Whereas character stream classes are split into two types: reader classes and writer classes. Reader classes are used for reading the data. Writer classes are used for outputting the data. Right. Now, here there are numerous stream classes, character stream classes are there. We are going to talk about only the commonly used reader classes, which are nothing but file reader and file writer. So here, file reader, which is used to read 2 bytes at a time from the source file. Right. How to write that file reader class? File reader in is equal to new file reader path to that file. Here, where is our file present in the system, that path will be given here. File writer, it is used to write 2 bytes at a time to the destination file. Now here, what is the syntax for using that file writer? File writer in is equal to new file writer. So here, path to the file, where our file is present, that path should be represented here. Right. Now here you can see an example for that. Now here I have written a class. I have written the main method. Now, if any exception is occurred, I want to throw that exception. That is in inputting the data or in outputting the data, I want to throw that exception. So for that, here we used IO exception, throws IO exception. Now here, first initially I have taken file reader in is equal to null, file writer out is equal to null. Now reading source file using read method and write to file using write method. Both I want to do. Now here I am trying to do. Now, whatever the object I declared here, I am using the same object. In is equal to new file reader. Now here, this one. What here, source is a text file, which is available in this path in my system. So whatever the characters that are present, 16 characters can be read at a time from this source file. Now, here I am using the writer, file writer object as out. Now I have written the same object, new file writer. So from this, whatever the data I read, that I want to write into the destination file. Now int C. So since I am reading the characters, I am writing C. While C is equal to in read is equal not equal to -1 out dot write of C. Whatever the character I read from the read function, those are written into the, those characters are written into the output function. Whatever the output I have taken from, so whatever the input I have taken in dot read. So from this in, we are reading. For write, for output, we are writing. Right. So this is a simple program which represents file reader and file writers, which are character streams. Right. So finally, let us see here this statement I want to do. So I want to close the input file and I want to close the output file. Suppose some data, if any data is not present in the source file, in that case, it throws IO exception. It throws IO exception. Or if the file is not found, source file is not found, in that case also it throws some exception. So at any case, if the file is opened, that should be closed. So for that, we are writing it in finally. Right. Since I used try catch, I am writing it is finally. Right. Now here you can see what are the different classes that are present in byte stream and character stream. Here you can see byte stream contains buffered input stream, data input stream, file input stream, print stream, buffered output stream, buffered data output stream, file output stream, and general output stream. All these are the different classes that are available in the now byte stream. Now character stream, buffered reader, file reader, input stream reader, output stream reader, print writer, buffered writer, and file writer. All these are the different classes which are available in the character stream. Right. Next, now what is the difference between byte stream and character stream? Now, byte stream operates on raw binary data and the data is processed byte by byte. Now, character stream operated on text data and it is processed character by character. So, byte stream operated on raw binary data, bytes of data. It processes bytes of data. Byte by byte, that data can be processed. It operates on text data, character by character, it processes. Now, it is suitable for processing non-textual data such as images, videos. This is suitable for processing textual data such as documents, HTML, etc. Now, here, input and output operations are performed using input stream and output stream classes. Here, we can use for performing those operations reader and writer classes. Now here suitable for low level input and output operations and it is suitable for high level because it allows 16 bits of data. It allows only 8 bits of data. Now here examples include file input stream and file output stream. Here examples are file reader and file writer. Now what is the difference between text file and binary file? Now in text file, text, character, numbers are stored. Whatever the text I want to store, that text, characters and numbers are stored one character per byte. That is, here that is 32,667, which occupies 5 bytes of data, even though it occupies 2 bytes in memory. So actually, when I represented this 32,667, when I want to store it in the memory, this can be represented with 8 bits. This can be represented with 8 bits, which becomes which takes 16 bits, which can be represented in a 2 bytes, which can be represented in 2 bytes in memory. So which can be represented in 2 bytes in the memory. Actually, when I am representing that in the binary, it takes only 2 bytes. But whenever I want to write this value in the file, in the text file, it occupies 5 bytes of space. That is, every character occupies 1 byte of space. 3 takes 1 byte of space, 2 takes 1 byte of space, 6 takes 1 byte of space. Like that, every character which is present in this takes 1 byte of space. Now, in binary file, data is stored in the binary format. Each data would occupy the same number of bytes on disks as it occupies in memory. How we are storing in the memory, in the same way, in the binary file, the data can be stored. In text file, the new line character is converted to carriage return or line feed before being written to the disk. Now, in binary file, conversion of new line to carriage return and line field doesn't take place. Now, text files are used to store data more user-friendly, and binary files are used to store data more compactly. So, in the text file, a special character whose ASCII value is 26 inserted after the last character to mark the end of the file. Now 26, so which is a special character which can be used to enter the end of which represents the end of the character. But in binary file, no such characters are present. Files keep track of the end of the file from the number of characters present. Now, content written in the text files is human readable, but content written in binary files is not human readable. It looks like encrypted content. Since it is entirely stored in the binary format, we cannot directly read by seeing the data which is present in the binary file. But in case of text file, the data what we are writing in the form of characters only, each character is represented in the form of a byte. So we can easily understand the data. This is the main difference between text files and binary files. Now we are going to see random access files. Now what is a random access files in Java? Random access file in Java is a class that allows data to be read from and written to at any location in the file. Now, a file may contain number of lines of data. Now, random access file is a class that allows to read the data or write the data from any location in the file. So in simple words, we can say that random access file class allows creating files that can be used for reading and writing data with random accessing. Random accessing means to store the data in any order that the user decides. So to access the stored data, random accessing means accessing of the stored data in any order. So first I can access the first line. Next I can access the 10th line. Next I can access the third line. Like that, according to the user desire, any data can be accessed at any place, at any location, data can be accessed. That is to be called as random accessing. So we can access data in the file in any order while using the file. Such file is known as random access file. Now, a random access file is a file that can be used for both reading and writing using random access file class. So here for doing that random accessing in the files, we can use random access file class, which is a predefined class available in java.io package. Now here you can see random accessing and appending the data to the files by using this example. So now here we are writing the main method. We want to try. So here file path is equal to this one. Here whatever the file that I want to use is this one. Now here I want to print a statement. Now read characters from file path 1 to 5. Whatever the characters that are present in the source file, I want to read those characters and I want to print those characters and write data to the file path. Now this data I want to write in this file at position 5. So is it possible to write that data at this position? Yes, it is possible. Now, whatever the data that I have, so that data is read from 1 to 5. So the data which is present from 1 to 5 can be read from the file what I have given. So after file 5, I want to write this data. Now the file content becomes this one. So initially the file content is this one. Now the file content, I want to try to write this one. So now the file content becomes written. Now again, I want to append some data in the file path. Now here, this is the appending. Always appending should be done at the end of the data. Now the file content becomes this one, right? Now, if any exception is catched, that can be traced here. Now, I want to show the random accessing. Now append data. Here we are taking another method, append data method. Now here I want to random accessing of the file, whatever the file path I given from that random accessing of the file I am taking. Now here I want to find the length of the file. Now I want to see the current pointer where it is present. Now from that current at that current pointer, I want to write some bytes of data. Right. Now here this is writing the data. So now here where I want to write, there I can write the data. This is the random accessing of files. So next I want to explain about serialization and deserialization. Now here, what are meant by serialization and deserialization? Serialization and deserialization are two important concepts in programming that allow objects to be easily stored, transmitted, and reconstructed. Mainly, the serialization and deserialization are used for transmitting the object data. For storing the objects, we can use this serialization and deserialization. Now here you can see they are used in various scenarios such as storing objects in a database, sending objects over a network, or catching objects in memory. For all these purposes, we can use these serialization and deserialization. Now here, our object is having primarily three characteristics. One is identity, state, and behavior. The state represents the value or data of the object. Always it represents the value or data which is present in the object. Now, what is the serialization process? Now, here serialization is the process of converting an object's state into a byte stream. Now, whatever the object's data that I have, here state is nothing but value or data of the object. Whatever the value or whatever the data of the object, that can be converted into a byte stream by using the process of serialization. This byte stream can then be saved into a file and it is sent over a network and it is stored into the database. The byte stream represents the object's states, which can later be reconstructed to create a new copy of the object. So whatever the object that I created, for this object, if I want to create a new copy by using the same state, same values, so this state can be converted into byte stream, and it can be transferred and it can be saved into a file. That file can be sent over a network and can be stored into the database. Serialization allows us to save the data associated with an object and recreate that object in a new location. Wherever I want to create the object, new object, there I can create that, recreate that particular object. Now, deserialization. Now here you can see the diagram which represents the serialization process. Now here I have the object. Now here I am using serializer. Now this serializer converts the state or the values that are present for this on object into byte stream to store the object into any of these states. So here it can be stored into a file, or it can be stored into a database, or it can be stored into a memory. So to serialize an object, the programmer must first decide on a format and then use appropriate tools to convert that object to that format. So whichever the tool that he want, how he want to convert the data, first he has to decide that one. Based on that, he need to select the tool and he need to save in that format, the state of that object into that particular format. Next, we are seeing that deserialization process. Deserialization is the reverse process of serialization. This involves taking a byte stream and converting it back into an object. So here in serialization, we are taking the data of the object, we are converting it into the byte stream, and we are storing it somewhere in a file or in a database or in a memory. We are in a memory location, we are storing the data, right? But deserialization is the reverse process. It takes the byte stream from the file or from the database or from the memory location. It deserializes the data. That is, it converts the data and it forms back into an object. That is, it recreates the object. Whatever the object here I have, that object can be recreated, right? So here in Java, object input string class to deserialize the binary format. For deserialization, we use object input stream class. This explains about deserialization and serialization in Java. So I hope that we completed all the topics which are present in this 15th module. That explains about different streams and different input and output files, and we are seeing byte stream, character stream, and differences of text and data, text and binary files. And we talked about various IO streams, system.in, system.out, and system.error, like that, various input and output streams that we talked. So this explains about Java input and output. So this is the last 15th module of your class, Java input output. So if you see, we completed our entire syllabus. Now, so I'll share you. So what the syllabus that we have completed in every module. In the first module, we talked about object-oriented programming concepts. So there we talked about what is class, what is method, and what are the object-oriented programming concepts that we have. That is encapsulation, polymorphism, inheritance, and then abstraction, all those concepts that we discussed, and basics about for entering into the object-oriented programming, that also we discussed in this. And in the second unit, we talked about introduction to the Java programming. So where we talked about different Java characteristics of the Java, and how to write methods in Java, right? So how to write a class in Java. So how to write a basic Java program, all these things that we learned there. And input and program control statements. So what the different input statements that we can use and what the different program control statements are that we can use. Those things were discussed. There we discussed about if else, else if ladder, etc., switch, etc. statements. And in the next module, in the fourth module, we talked about looping statements. There we talked about different looping statements such as while, do while, etc. Now I'll share you one more document. Right. In the fifth class, we have a deep discussion about classes, objects, and methods, how to create object and how to use reference variables, how to write a method and how to return values from method and how to write parameters into the method. And we talked about constructors, different types of constructors. And we also talked about this keyword. And we talked about finalize method and garbage collection, all these things that we discussed in the fifth module. And coming to the sixth module, we talked about concepts of overloading and inner class. We talked, right? So overloading, which itself explains about the object-oriented programming concepts, which is nothing but polymorphism. And then we talked about arrays, and then we talked about strings. So here we learned that string is not simply a character array in case of Java. String is a special class in Java, right? And we talked about inheritance, which is another object-oriented programming concept. So there itself we seen overriding also. Overriding is nothing but which represents the polymorphism at runtime. Now, interfaces, we talked about the abstraction here. Interfaces are used to provide more abstraction, right? There itself, we talked about abstract classes, right? And packages, we talked about packages, which provides reusing of various classes and interfaces. And next, we talked about exception handling 1 and exception handling 2. There we talked about different Java keywords that can be used for handling the exceptions and what are the different types of exceptions and how to handle all those exceptions, all those things that we explained in these exception handling 1 and exception handling 2. And after that, we talked about multi-threaded programming. There we talked about how to create the threads using threadable thread class and using runnable interface, how to create multiple threads. Also we talked, and what about the thread priorities? And what about the synchronization in threads? How the synchronization can be achieved in threads? All those things that we explained. And we seen all the practice programs also. So whatever the practice programs given in your syllabus, all those practice programs also we discussed. And finally, we talked about Java input output. That is, there we are talking about general input output streams, and we are talking about byte streams and character streams, and also so what the differences between text files and binary files, and what is meant by random accessing out files, and how to convert the objects into the byte streams, as well as those how the byte streams can be again recreated as the objects. So which is nothing but serialization and deserialization process. So all these things that we discussed in this object-oriented programming concepts. So if you have any doubts regarding these all, so you can contact me. So we can talk, we can take a special class and we can talk about those particular concepts in which you have the doubts. So thank you for listening the session. Thank you. I'm winding up.